So we have talked about factoring out the greatest common factor, which is always what we check for first. And we have talked about factoring by grouping, which is something that we use when we have four terms and we end up finding a binomial as our greatest common factor. What we're going to focus on in this last section, and we're going to do an excessive amount of practice in class on this, is factoring a polynomial using guess and check. So when all of our other methods have failed, this is the approach that we're going to take to do this. But before we really jump into how to factor using guess and check, what I would like to do is remind us sort of our opposite approach. And we're going to go back in our minds to Unit 7 where we talked about actually multiplying a polynomial out, and we're going to look at a problem like that. So when we multiplied with polynomials, and I know that not all of you liked the box approach, and some of you might change your mind in this unit. You might really like the box in what we're going to do now. But what we did was we took each factor, each set of parentheses, and we wrote it along one side of the box, and then we multiplied together to fill in the box. Minus 4x plus 1x minus 2. And then we simplified this out by combining like terms. This is going to become, this is 2x squared minus 3x minus 2. And we worked from the product all the way down to get us to the polynomial. Right? We started with parentheses and we distributed or used the box method to multiply out to get rid of parentheses. In this unit, we are going to do the exact opposite of that. Our goal in this unit, our goal is to get the two sets of parentheses, as opposed to before our goal was to get rid of them. So we are really working in reverse. Our goal is to figure out which two products or which two factors multiplied together to give me the polynomial. So before, the polynomial was our answer, and now the polynomial is going to be our original problem. So looking at this, knowing that our ultimate goal is to make two sets of parentheses, I want to use the box method as sort of a guide to help you figure out where things go. So if you look at this example on the left, I want you to identify where in the box was 2x squared. Where in the box was 2x squared? And I'm hoping that you just looked to the left and you said, oh, that was in the top left box. And I also want you to look and I want you to identify where in the box was -2. And I'm hoping that you looked down and you said, oh, -2 was down here. And you should be thinking, what about the middle? And that's a great question. Where does the middle show up? And the middle shows up when we combine these two factors together. So I'm actually going to write that over here. So the very first thing that I did after making the box, which I did for you in these notes, was I filled in what I know goes where in the box. Now what I'm going to do is I'm going to try and figure out what goes on the outside of the box. So I am asking myself, in this box is 2x squared. To get 2x squared, I need to multiply something here and something here together in order to get 2x squared. So what could I multiply? So what makes x squared? Well, x times x makes x squared. And if I want it to be 2x squared, I'm going to need a 2 in front of one of those factors. Then I'm going to ask myself, okay, well, these last two numbers need to multiply. -2 I need to get from multiplying these two things together. And when I multiply those two things together, I should get -2. Well, the only way to multiply to get -2 is 2 times -1 or 1 times -2. And since we already kind of have our answer over here, I'm going to go with what we can see there. So I'm going to put a -2 here. I'm going to put a +1 here. And I'm going to fill in the box to make sure that my middle term actually does, in fact, add together to be -3x to make sure that I'm right. So if I fill in this box, I get +1x. Over here, -4x. If I add -4x and +1x, I do, in fact, get -3x. And now I'm going to write my final answer. And my final answer are the binomials that are on the outside here. So 2x, that's really hard to read. Let's try this again. 2x plus 1 and x minus 2. The more you practice this, the better you're going to get at it. And I'm going to tell you that sometimes you're going to be working through these problems and you're not going to get it right the first time. And that's okay. That's just like learning any new thing. But let's really focus for the rest of this video on making sure you understand the process one part at a time and really giving you that extra practice. So let's look at number 1. What I want you to do right now is fill in everything that goes in the box that you know, not the diagonal boxes. We don't know what goes in those 2 diagonal boxes, so not this one and not this one, but what goes in the other 2 boxes. Pause the video and do that. So I'm hoping that you identified that x squared should go here, and that positive 1 should go here, and that 2x should go over here. So I have now used each part of the trinomial that was our answer, and I have put it in its appropriate place in the box. Now I'm going to ask myself that same question that I did last time. I need to multiply 2 things together in order for this top left box to be x squared. Well, what am I going to multiply together? I'm going to multiply x times x. And then in these 2 outside boxes, I need to multiply something together to give me 1. Well, there's only one way to do that. I'm either going to multiply 1 times 1 or negative 1 times negative 1. Since everything in this problem appears to be positive, I'm going to assume that my factors are going to be positive. So let's go ahead and fill in the box here. So 1x, 1x, and 1x plus 1x should give me 2x, which it does. So I have checked that everything works correctly, and my last step is just going to be to write out the 2 factors that multiply to give me this polynomial. So remember, your answer now is the factors. The polynomial, in this case the trinomial, is the original question. And you could also write this one, this is a special product, like this. So we started by filling in what we know in the box, and what we know goes sort of in this outside spot of the box. Then we asked ourselves what multiplies to be the top left box, or the part in blue, what multiplies to be the bottom right box, or the part in the purple. We checked with our 2 red factors in the diagonals that they added together to give me my middle term. And then we rewrote our final answer as the product of 2 binomials. And again, I want you to know we're going to spend so much time in class practicing these together that I don't expect you to be an expert right now. But I want you to do a quick check. What I want you to do is look at the 3 remaining problems. I want you to pause the video and fill in the 2 boxes and the outside part for each of these 3 remaining problems. So I want you to fill in this box on each of these 3. Actually, I'm going to have you wait on number 4. And I want you to fill in this box. Oops, that's not purple. And I want you to fill in the number that goes here. So go ahead and pause the video and do that for me. All right, I'm hoping that you had time to fill in the parts that I asked you to on numbers 2 and 3. Now we're asking ourselves, so if you can get this far, I want you to realize you're already halfway there. If you can figure out what goes where in the boxes, that's a great place to be. And I really want you to be able to self-check. I can get to this point, but maybe you're stuck after here, because the best way that I can help you is when you can come in and say, I know how to fill in the boxes, but I get stuck at this part. So really kind of, if you're getting stuck, I want you to be able to diagnose your issue. That way I can better support you in class. So what makes 2x squared? Well, 2x times x. And what makes 12? Well, there's a lot of things that multiply to be 12, and I'm just going to list them up here. 1 times 12, 2 times 6, 3 times 4. That's a lot of different options here. A couple of things that I want to point out before we just jump in and guess one right away. At the beginning of this problem, this trinomial does not have a greatest common factor other than 1. Nothing evenly divides. And what that means is whatever number goes here, it cannot be divisible by 2. Because then there would be a greatest common factor in this factor, and that is not true for this trinomial. So that actually eliminates a lot of options. If this number right here can't be an even number, that leaves us with 1 or 3. So let's go ahead and guess. Let's go ahead and guess 1. If this is 1, then this has to be 12 in order for these two things to multiply together to give us 12. So now, before we assume that we're right, we need to check our diagonal boxes. So this is going to be 2 times 12 is 24x. This is going to be 1x. 1x plus 24x is not 11x. So we are not correct. This does not work. And that's okay. And if this happens, you can just cross out this box and you can draw a new box. Because I'm working digitally, I'm going to erase my box. And I'm going to try something different. So if this, we just figured out this can't be 1 and 12. It can't be 2 and 6 because this number is not allowed to be even because then there would be a greatest common factor. So we're left with 3 and 4. So let's check 3 and 4. And let's fill in our boxes. This gives me 8x. This gives me 3x. 3x plus 8x is 11x. Now we can make a happy face here. We are right. And our last job is to write our answers out as our factors, 2x plus 3 times x plus 4. Or it doesn't matter. Just remember, this is multiplying, so we could write it in the other order as well. Either of those would be correct answers. But I don't really want both of them to be there, so I'm going to erase the bottom one. So fill in what you know for the box. Check your options. Guess something. And I'm using that term guess really loosely because in reality, we're making a very educated guess based on what makes x squared or 2x squared and what makes the number in the bottom of the box. So let's go ahead and look at number 3. I want you to pause the video and see how far you can get on your own for number 3. Okay, what makes x squared? X times x. What makes 35? Well, 35 is 1 times 35 and 5 times 7. So I'm going to try 5 and 7. And if I multiply here inside, that would give me 5x and 7x. And that wouldn't give me negative 12x. It would give me positive 12x. But I need to multiply to be positive 35. So what happens if I just make these both negative? This would still be positive 35, but now this would be negative 7x and negative 5x. And if I combine these together, that does give me negative 12x. And then my final answer is writing the two factors that are along the outside below my box. So something that I haven't done a great job of making sure you're checking at the beginning of these problems is that you always need to first check for a greatest common factor. So if you look at number 4, I'm hoping that before you start filling in the box, you actually notice, hey, wait a second. This has a greatest common factor because noticing it at the beginning of the problem is going to make your life so much easier. And I will do this problem as well in case you didn't notice it at the beginning. But this has a greatest common factor, which is 4, which means I can factor out of 4, which means my final answer is going to be 4 times something else. So now I'm going to make the box with just this inside of parentheses. So in here is going to be x squared. Down here is going to be negative 4. And I want you to notice there's no term that just has an x. So the middle term is the term that has an x. And there isn't one here. So I'm going to put 0x over here. And I'm going to ask myself, what multiplies to be x squared? Well, x times x. What multiplies to be 4? Well, if I check, negative 4. Negative 4 and positive 1. That's going to give me 1x minus 4x. That's not going to give me 0. So scratch that guess. That didn't get me to where I needed to be. So what else makes 4? 2 and 2. So what if I do negative 2 and positive 2, since it needs to multiply to be negative 4? 2x, negative 2x. This looks like it is going to give me 0. So I can add my smiley face here. I'm happy that this works out. So I'm going to have x plus 2 and x minus 2. So 4 times the quantity x plus 2 times the quantity x minus 2, that's going to give us our factored version of 4x squared minus 16. And you may remember from last unit that this actually has a special name. This is called the difference of squares. And I'm going to talk about that in my video for the next section. But it is great to notice. And you may have noticed that number 1, this is a perfect square. This was a perfect square trinomial. You may have noticed that as well. The very last thing that I want to talk about is some of you are going to be the way that I am sometimes, and you're going to do problems like number 4, and you're going to not realize that there was a greatest common factor first. So I'm going to pretend like I didn't realize it. I'm going to redraw my box here. And if I didn't realize it, I would have put 4x squared here, and I would have put negative 16 here, and I still would have put 0x because there's no term in the middle that just has an x. And then I would have said, well, what makes 4x squared? Either 4x times x or 2x times 2x. And what multiplies to be 16? Either negative 4 and positive 4, or 16 and 1, or 2 and 8. And then I would have filled in this box to check 8x, negative 8x. Oh, look, this is 0. So it still works. But if I write my factors out, 2x plus 4, 2x minus 4. Right now, I should realize that these are both even, and these are both even. And that should make me think, uh-oh, there was a GCF at the very beginning. And now that I have forgotten to do that, I need to factor it out at the end. So what I'm going to do is I'm going to take it out of each of these terms. That's going to leave me with 2 times x plus 4. And I need to take it out of each of these terms, 2 times x minus 2, and this looks kind of silly. Let's move these 2's together. 4 times x, that should be a 2, plus 2 times x minus 2. So it's a lot harder to realize it at the end, and if you leave your answer like this, you're going to lose points because this is not factored completely. It is factored correctly. You just haven't factored it as much as possible, and that's really what we want to look like. We want to get it factored as much as possible because in this class later and in future classes, you're going to be using these factors to solve different types of problems. So we need to be able to factor completely. So we are going to do more practice on these problems in class. Don't worry, we have tons and tons in store. You're going to feel better about it a little bit more each day, and I look forward to supporting you on this in class. Thanks for listening.